Hi guys, so I wanted to share you some prompt engineering tips that I saw on this guide released by Lee Boonstra, who works at Google. I think these are very practical advices that could work both if you're working with code or if you're just using ChatGPT or whatever LLM you use. So yeah, let's get started. Now I've set up this notebook with some examples to show what they show here on this guide. Let's start with the LLM settings in general. So I'm using Gemini. Essentially, what we have here is the basic setup for using an LLM. I've created this helper function that takes some config and a prompt, and I can just call LLMs in for loops and functions if I have to. So starting with the LLM settings, there's a few tips on temperature, top P and top K, which I think are helpful, and to show some examples of the effect that we have from temperature. I've set up this example where I'm asking the LLM, and here I believe we're using Gemini 2.0 Flash. So I've asked Gemini for an idea for an AI consulting company, just a name, nothing else. And then with two different values for temperature, 0 and 1. These are extreme values for Gemini, where I believe temperature only goes from 0 to 1. I think in ChatGPT it goes from 0 to 2. So temperature is a sort of randomness parameter. If it's 0, it means your code will always return the same answer, or Gemini will always return the same answer. Whereas if it's very high, it means there's a lot of randomness, and each prompt, the same prompt will yield different answers each time. And we can see this here. For temperature equals 0, each time I call an LLM with this question, it gave me the exact same answer. Whereas when I set temperature to 1, it gave me 3 different answers each time. Sometimes the randomness can be helpful, sometimes it can be harmful. So if you're working with more deterministic approaches and you need, code and reasoning, I think it's usually better to have temperature equals 0. Also, if you need reproducibility. Whereas if you need something more creative and some more natural language, let's say, in your text, having a high temperature can help, avoid or at least reduce that feeling of AI generated text. Now, top K and top P are a bit different. These are the 3 parameters that you usually set, although in ChatGPT, you do not set top K, I think. You only set temperature and top P. And I believe usually working with just temperature and top P is enough. And that's the reason why I'm going through Gemini, is just to show top K here. But because the GPT API will not take top K, but you can see, so top K is essentially how far will you go when selecting the next token. So the way an LLM works essentially is, for a given prompt, it will try to estimate the most likely next token, and there will be usually a set of tokens from which the LLM will sample. Now, the higher the top K, the bigger this sample is, and the temperature is essentially how skewed the probability distribution will be across those tokens. So temperature equals to 0 means the first most likely token will have all of the probabilities, and the rest of the tokens will have none. And top K helps you filter up to when can you sample. So high top Ks mean you can go further and then have more randomness, let's say, in your response. And the top P is more or less the same logic. It's the top probability that you're willing to take. So I found that top K is less useful than temperature and top P. If you have two of those three, usually temperature and either top K or top P, it should be enough. So you don't have to worry about the third parameter. But I still put some examples here of top K. So top K equals to 1, you have less variability, whereas high top K, you have more variability. But the most interesting one, I think, I usually work with is a top P. And then you can see a top P when it's very low, you get more or less the same responses. And when you increase it, you can get a little bit more variance. Now, what are the values that they suggest on the prompt engineering guide? At least as a starting point, it's these ones. So temperature equal to 0.2, which is not very high. Top P, and top K equals to 30. And it's usually a good starting point, and then you can work with these. I'd advise you maybe not to use top K and just work with the temperature and top P. It also makes your code more robust if you ever want to change from, let's say, Gemini to GPT. You are already within the same parameters. Now, enough with the settings. Let's move on to prompting techniques. I think there's some very useful ones, and some that are a bit outdated, given the best capabilities of most recent LLMs. Now, chain of thought for me is one of those that might be slightly outdated. So here's an example of how chain of thought works. First prompt is just a sort of math puzzle. When I was 3 years old, my partner was 3 times my age. Now I'm 20 years old. How old is my partner? Now you can see that the first time I try this, the prompt is just a question. The second time I try it, I've added these let's think step by step. And if we look for chain of thought here, you can see I've copied this example, and in their example, the answer here not only is wrong, but it's just a plain simple answer. Whereas here, when you add these let's think step by step, the LLM gets the right answer because it added these reasoning steps. Most LLMs, like the newest models, they usually just do that already. Like you don't have to add these let's think step by step. They are already capable of laying out some logic before trying to answer. So I don't think this is the most useful one. It's still useful to know if you ever need it. Self-consistency can be useful, however, although it can also be very expensive depending on how we do it. It's useful, in my opinion, for classification tasks. It's very common these days to use text classification with LLMs instead of the classic methods. So you're trying to classify an email if whether it's important or not important based on the content. Now, this is an important email because it says you've been hacked, essentially. And the way you do it is you're asking the LLM to just classify it as important or not important. And the way self-consistency works, and I think it's a good approach for classification, is to ensure higher consistency and higher quality of the answers. For each example, you ask your LLM 3 times to classify it. And then you have this array, this list of classes for the same email, which you can then take, the most common value out of the three. In this case, it was important in all of the three calls. But if it's ever the case that you have, two important and one not important, you know that it takes some of the randomness out of it because you're taking the majority. Now, one-shot and few-shot prompting is super useful. Explaining to an LLM what you want can be tricky and hard, but if you just give an example, things get much simpler and results are usually better. Of course, you can explain and give an example. So here I've asked the question, what is gradient descent? It gave me a very detailed and thorough answer. I could add some explanatory text here, like, hey, I want a simple answer, one sentence, whatever. You could explain the format you need, but it's much more helpful if you just give an example, like in here. I have an example of a question, what is overfitting? Then an answer, which is just one sentence. And then I ask my question, what is gradient descent? And then I have this sort of like one or two sentences short answer of what is gradient descent. So one shot or few shots, it just means like how many examples you're giving. Given a few examples of a few extreme, few edge cases, I think it's very helpful. And I use these all the time. Next is system prompting and structured output. Now, system prompt. So let's say I'm asking for a definition of precision in machine learning. I've got this definition. Let's say I need a sort of structured output. I can use system prompt and structured output to get an answer the way I need. So you can use Pydantic, for example, to define a class. So in my example here, the class is a concept. I need the explanations and definitions of concepts in machine learning, for example. So I define a concept as having a term, a definition, and an example. And then when I ask define precision in machine learning, I have the system instructions asking to respond in JSON with these following fields. And then I give the response schema with term definition example. So that ensures that I always get these JSON-like object that I can then turn into a dictionary and get my term, my definition, and my example. This is also super helpful to structure unstructured text, and I also use it all the time. For me, these are the sort of highlights from this guide, but it's not very long. It's a few pages long, and I really suggest that you take a look into this guide, some of the examples, even though some of them might be outdated. For me, these ones that I've laid out here are the most important ones. And also, if you want a more detailed guide on prompt engineering, I really like this one, promptingguide.ai. When you have like the basics of prompting, you have zero shot, few shot, you have RAG, you have React, you have a lot of more advanced stuff. You have some explanations on models. I think it's really good. Again, models are evolving super fast, so often some of these advices get outdated. Still worth it taking a look, I think. And if you want to play around and test stuff, I recommend you check out OpenAI's prompt playground. It's on the OpenAI API platform. If you check the playground page here, you get to choose different models. You get to set temperature and top P, max tokens. You can use tools if you want, and then you can give both system messages and use the chat. This helps you iterate much faster and test your results. That's it. Hope you liked it, and let's keep on building.